At JLI, we dedicate time to researching new technologies and methods in vision, and in this video, I will uncover how we are working to solve one of the big challenges with machine learning for quality control. Machine learning is an integral part of many of the vision systems we create, but often the use of ML is associated with a fundamental challenge. Let's take a typical scenario. As a customer, you need to implement a new production line and want to use machine learning in quality control. If the model is an artificial neural network, it requires a lot of images of both good and faulty items to train on. And of course, you don't have these images because the production line is new. At best, you have a handful of defects from an initial production test, but you could need thousands. Getting enough training images is one of the fundamental challenges that we dedicate research time to solving, and we are well on our way. We tried several methods, but the most promising is using 3D rendering software or game engines to create digital twins of both our entire vision setup with camera and lights and the items to be inspected. The process looks roughly like this. Let's say we have an item with a defect. By 3D scanning the item, we can create a digital twin of the item, and we can then move the defect, manipulate it, and place it elsewhere on digital copies of the item. We can also, so to speak, record a defect from a different item with a 3D scanner and then move the defect onto the digital twin, and that way we can reuse the defects across applications. With the digital version of our vision system, we can now generate an image of the item with the simulated defect, and because we have built our entire vision system digitally, it will look like an image that was taken with the real-life setup. In this way, we can start with a physical item with a specific defect and use it to create digital copies with simulated defects. In this way, we can generate a lot of different images with errors that we can use to train our neural networks and make them much more robust. Building the digital twins of vision systems and objects is still a very time-consuming process, but developments in 3D scannings are extremely fast, so it keeps getting easier. We have the technology and the process in place and have tested it in real-life applications with convincing results. And we have also started implementing it in our projects. Next step is to develop it further and make it commercially viable. And then we will be able to deliver robust and trained neural networks much faster and cheaper than what is possible today.